Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Symmetry Through the Fog by Megan33, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. There is one and only one gray palindrome line, which reads the same forwards or backwards. So, for example, this is the same line because there's only one gray palindrome line. And it must read the same going this way as it does going this way. And that is how the palindrome line works. We have digits in a cage do not repeat and sum to the clue in the top left. So, for example, these digits add up to 6. So if we say had a 1 here, this would have to be 5 because these digits must add up to 6. And those are also known as killer cages. We have a black dot between cells indicates cell values with a 2-to-1 ratio, and a white dot between cells indicates cells with the consecutive values. Not all dots are given, and these are otherwise known as Kropki dots. So, for example, say we had a 2 here. Then this would have to be 1 or 4 to maintain the 1-to-2 ratio between them. And say we had a 6 here. Then this would have to be 5 or 7 to make sure that these digits are consecutive. And those are examples of how Kropki dots work. And finally, we have the grid is partially covered with fog. Correctly placed digits will clear the fog around that cell. No guessing is required. So this is standard fog of war rule set. So say we placed a correct digit in this cell. It would clear the fog in the 3x3 square that is centered on that cell. So it would clear the fog, including in its own space, and it will clear the fog in that 9-cell region. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so these are the same digit. These two are the same digit. So these two, this digit must be consecutive with these two, right? And since they're the same row, they must be two unique digits. So this cannot be 1. Okay, so for the cage here, you either have 1, 5 adding up to 6 or 2, 4 adding up to 6. This can't be 1 because 1 is consecutive with only one unique digit, 2. So that's why it can't be 1. So this can't be 1, which means this can't be 5 to add up to 6, and this can't be 1 for the same reasoning. If this were... So, and also we know this digit is in a 1-to-2 ratio with both of these cells, because again, this is the palindrome. So, and these two are in the same row, so you cannot have the digit is in a 1-to-2 ratio with 2 unique digits. Their only possible combinations for that are 2 and 4. So this is 2 and 4, which eliminates 2 and 4 as a pair to add up to 6. Because that would eliminate all possibilities for that cell if this was 2 and 4, right? So again, 2 can be next to 1 and 4 in a 1-to-2 ratio. 4 can be next to 2 and 8 in a 1-to-2 ratio. So basically, that's the reasoning why this is 2 and 4. No other digit is in a 1-to-2 ratio with 2 unique digits. So this has to be 1 and 5 then. So this is 1, this is 5, which makes this 5. 2, 4. So 2 and 4 is in a 1 to 2 ratio with 2, 4, or 8 here. So 5 is consecutive with 4 and 6. So this must be a 4-6 pair, which means this digit cannot be 4 or 6 because of the 4-6 pair in the row. So this can no longer be 4, it's 2. So that's 2, which makes this 2. 2 is in a 1 to 2 ratio with 1 and 4. This can't be 1 because of 1 in the box, so this must be 4, which makes this 1. 4 eliminates 4 here, so that's 6, which makes this 4. These digits are the same. They add up to 13 with this digit. So this must be 4, 9, 5, 8, 6, 7. And this can't be 4, 5, or 6 because of 4, 5, 6 in the box. So this is 7, 8, 9. This is 7, 8, 9. And this is 4, 5, 6. This can't be 4 because of 4 in the column. So that can't be 9. So this can't be 9. That's 7 or 8. And this digit has to be consecutive with 5 or 6. And it's the next one on the palindrome line, so this is the same as that. And it must be then 4, 5, 6, 7. It cannot be 4 again because of 4 in the column. So this must be 5, 6, or 7. This cannot be 5 because of 5 in the row here. So this is 6 or 7, which means this has to be 6 or 7 here. Well, to add up to 13, you can no longer have 6 and 7 because that would eliminate all possibilities for that cell there. So this must be 5 and 8. And therefore, this is 6 to be consecutive with 5. So this is 6. So we have 8 here. This is 6. And then these digits must be the same. And these digits must be the same. So what can these digits be? We can have 1, 3, 7, 8, or 9. So it's the same here. This can't be 8 because of 8 in the box. So these are all odd digits, which makes this having to be an even digit. But it can't be 2, 4 because of 2 and 4 in the column. So this could only be 6 or 8, which is only consecutive with 7 or 9 here. So this is 6 or 8. Can't be 1 or 3, so this can't be 8 because of 8 in the row here. And again, this is the same as that digit because of the palindrome, so this is 6. So we have 6 and 7 here, and that forces this to be 6 and 7. These digits are the same. We have 1 to add up to 9 for a cage. We have 1, 8, 2, 7, or cannot be 3, 6 because of a 6 in the box, or 4, 5. But we know this goes this way and then this goes there. So this line has to go this way. So this cell has to be related to that. That means we can eliminate 1 and 5 from this cage. So it can't be 1, can't be 4, 5. So it must be a 2, 7 pair in this cell and that cell. And this can't be 7 because of 7 in the row. That makes that a 2, which makes this a 7. That leaves that as a 2, which makes that a 7. Okay, remaining digits in this cell here. We can have 3, 4, 8, and 9. And this is 3, 4, 8, and 9. So that's kind of limited. To add up to 8 here, we have 1, 8, 1, 7, but that's not possible because 7 in the box. So it has to be 2, 6, or 3, 5 here. We don't know which. This digit can only be, cannot be 2, 4, 6, or 7. And that matches this digit here. So remaining digits in column 5 are 3, 4, 8, and 9. Okay. This can't be 8 here because of 8 in the column. So therefore this can't be 8. This digit matches this. Again, it could be 1, 3, 5, 1, 3, 5, 8, 1, 3, 5, 8, 9. Okay, 1, 3, 5, 8, 9. Well, this digit is consecutive with this. To add up to 8, you have to have a digit less than 8. So we can't have 2, 6, and 7. So that leaves 1, 3, 4, or 5. 8 and 9 are not going to be consecutive with any of those digits, so this can't be 8 or 9, and we can't have 1 here because of the 1 is only consecutive with 2. So I think that has to be 4 then here. Right? This is 8 and 9, which makes this a 3-5 pair, so this cannot be 3-5 to add up to 8 here. This is 2-6 as a pair. Actually, we kind of knew that already. 6 had to be one of these 3 digits. 2 had to be one of these 2 digits, so this had to be 2-6 as a pair. This is 3-5 as a pair that's only consecutive with 4 out of the digits possible here. So this must be 4. This is 3-5. That means these digits are the same, so this is a 1-3 pair. So this must be a 1-3 pair here, which eliminates 1 and 3 in the rest of the row, so this can't be 3. This can't be 3 because of the 1-3 pair in the row. This is 4, 8, and 9. It cannot be 4 because of 4 in the column, so this can't be 4 here. And we don't know where this goes. It could be that these are the same digit. It could be that they're different digits. Okay. 1 has to be one of these digits here. Let's figure out what the remaining digits in row 3 are. 1, 3, 8, and 9. This cannot be 1 and 8 because of the 1, 8 in the box, so this must be a 3, 9 pair, which eliminates 3, 9 in the rest of the row, so this is 1, 8 as a pair. That leaves the remaining digit in this upper central box as 7, because we have a 3, 9 pair, and everything, every other digit is already accounted for. So this is 7. Okay. Where is 7 in the central box? It can no longer be here or here or here or here because of 7's in the rows and columns. So this has to be 7 here. Where is... Okay. Let's see. This is 1, 3 as a pair. Okay. Where is the 1 in this lower central box? Can't be here because of the 1, 3 pair. This is 2, 6 adding up to 8. This has to match that, and 1 is not consecutive with 4. So 1 has to be one of these 2 digits, which means a 1 eliminates... That means 1 is guaranteed in one of these cells here, so this cannot be 1. This is 3, which makes this 1. That corresponds to this being 3 and this being 1. So then these 2 digits are the same. 1 eliminates 1 here, so it's 8, which makes this 1. This digit is the same as this. What are the possibilities? No 1, 2, 3, so it could be 4, 5. No 6, 7, 8, it could be 9. So this is 4, 5, or 9 here. That's fine. What are the remaining digits in column 4? We have 3, 5, 8, and 9. Okay, that's fine. That means this is 3, 5, 8, or 9. It cannot be 3 because of 3 in the row. This can't be 8 because of 8 in the row. Where's the 2 in this left central box? Cannot be here or here because the 2 is in the rows. Can't be here because the 2 in the column, so it must be here. So that's 2. Therefore, 4 cannot be here in this left central box. It must be one of these 2. Where's 4 in column 2 then? Cannot be any of these because of 4 in the box and 4 in the row, so it has to be one of these 3. 2 in column 3 cannot be here because of 2's in the boxes. Can't be here because that's filled, so one of these is 2. Okay. This can't be 3 because of it must match that, so this is 4 or 9. Um, 1 in row 8 has to be here because it can't be here because of 1 in the box and 1 in the row column there. So one of those is 1. Where's 1 in this left central box? Can't be here because of 1 in the column, so it must be here. So this is 1, which eliminates 1 being here, which means 1 in row 8 has to be here. That eliminates 2 as a possibility from being here, so 2 must be here, which makes this 6 and 2. 6. We have okay, remaining digits. Where can 1 be in the central box? Cannot be here anymore because of 1 in the row, and it can't be here because of the palindrome. Can't be here because of 1's in the column, so it must be here. So that's 1. And where's 1 in this right central box? Can't be here because of 1 in the column, and this is the palindrome also, so 1 must be there. So that's all the 1's done. 2 can be either of these 2 in row 2 and can be either of these in row 9. 3, where can 3 be in this lower central box? It can only be here because of 3's in row 7 and 9. Eliminates those possibility, and this cage eliminated the possibility of 3 being there. So this is 3 here, which eliminates 3 here, so this is 9 and 3. This can't be 3 or 9. This can't be 9, so this is 5 or 8. This is 5 or 8. 3 is one of these 2 cells here. This, what are the remaining digits in this left central box? We have 3, 4, and 9. Obviously, this can't be 4. Everything else is fine. Okay. What are we guaranteed here? This must be 8 or 9. Guaranteed. Right, this is because this is a 3, 5, 8, 9 triplet. Or a quadruplet with this cell. Remaining digits in column 6. We have 4, 5, and 9. And this can't be 4 because of 4 in the row. We have a 3, 5, 9 triplet in row 6, which eliminates 3, 5, 9 in the rest of the row. This can't be 3, 5, or 9. It's 8, which eliminates 8 in the rest of the box. Okay. 3 is not very limiting. 4s is not very limiting. 5s, not very limiting. 6s, I think we already tried that. 6 has to be one of these 2 digits here. Not limiting there. It has to be one of these 2 digits here. 7 cannot be here because of 7 in the column. Can't be here because of 7's in the rows. So what 7 has to be one of these 2 digits here, which means this is a 6-7 pair. Because those are the only places they can be in that box. 7 can be one of these 2 digits here. 8. 8 cannot be here or here, so 8 has to be here, which forces this to be 9 there. And that leaves this as a 3. That means this must be a 2-9 pair here, because those are the only remaining digits in row 2. Row 1 has to be 3, 4, and 5. Well, this can't be 3 or 4 because of 3 or 4 in the column, so this is 5, which eliminates 5 here and here. One of these digits is guaranteed to be 9, so this can't be 9 here, therefore this is 2, this is 9. That eliminates 2 as a possibility here, so therefore this is 2 here. This 9 eliminates 9 here, so that's 8, which makes this an 8 for the palindrome. That eliminates 8 here, so this is 5, which makes this 8. So this is no longer could be 8. We have a 3, 4, 9 triplet in the central box, so this can't be 3, 4, 9. It's 5, which forces this to be 3. Oh, though we had that already there. 3 eliminates 3 here, so it's 9, which means this cannot be 9 either way there. This 5 eliminates 5 being there, and this 3 eliminates 3 being there, so this is 9. This can't be 3 or 9. It's 5. 9 eliminates 9 being there. So this can no longer be 5. So this can no longer be 5 because it's a palindrome. 3 eliminates 3 here, so this is 4 and 3. 4 eliminates 4 here, so that's 9 and 4, which means this can't... that's wrong. This is 9 and 9 because this is a palindrome, so 9 eliminates 9 here, so it's 4, which eliminates 9 here, so it's 4. And that's palindrome. 4 eliminates 4 here, so it's 3 and 4. This can't be 4, it's 3. This can't be 3 or 4, it's 9. And the rest we probably would be able to learn from just normal Sudoku. This can't be 4 anymore. We have 7, 8, 9 as the remaining digits in row 7. This can't be 8 or 9 because of 8 and 9 in the column, so this is 7. This digit must be a 5 here. We have 8 and 9 remaining in row 7. This can't be 8 because of 8 in the column, so this is 9 and 8. These digits are consecutive, and we have 5, 6, 7 remaining, so the consecutive digits are either 5, 6, or 6, 7. Either way, we have a 6 here, right? Which means this can't be 6, this is 7, which makes this 6. So now we have a 5, 6 pair in column 1. This can't be 5 because of 5 in the row, so this must be 6, and this is 5. We have 4, 7 remaining in column 2. This can't be 7 because of 7 in the row, so that's 4 and 7. And that leaves this as a 4 and this as a 6. And that's how you solve it. Yep, fairly straightforward. I really actually liked the palindromes and sort of the step-by-step nature that you sort of had to go down. I don't know, it was very... Sometimes it's just nice to go step by step through a process and then just see it grow to like actually the solve, right? And I guess, I mean, that's just in life, but like that also applies to Sudokus. It was just very satisfying, fulfilling, oh, okay, we got this right, we got this part right, and just keep continuing down the palindromes. So it was very nice. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.